Okay, so this video is meant for my Algebra 2 students coming from CVCC. We're going to have a test over Chapter 7 when we get back from spring break. So in order to try to help you remember some things, I put this video on prior to spring break so that you can maybe view it over spring break and then view it before the test. Okay, so we'll just cover some questions from 7.3, 7.4, and 7.6. The other sections are covered in my previous video. Okay, so let's take a look at this first question here. The first question says, use the given functions to perform each operation. And I'm going to put some operations below here. And then we need to state the final domain. And here's our four functions. All right, we have f of x, g of x, h of x, and p of x. Before we begin with the operations, and I'll show you them, I want to look at these domains individually. So the domain of f. X squared plus 1, this is a quadratic. A quadratic is a U-shaped parabola with arrows on both ends, all real numbers. G of x, we need to remember that this x to the negative first means 2 over x. So the domain of g, there's an issue, right? There's an issue because you have x on the bottom. X cannot be 0. So to write that, we'll say negative infinity to 0, union with, and I'll go below to save space, 0 to infinity. So that says x can be any number but 0. Okay, h, the domain of h. X plus 3 is a linear function. A linear has arrows on both ends, all real numbers. And then lastly, p. Well, we have to remember that x to the 1/2, this is the square root of x. And square roots are even indexes, which means there is a domain issue. Inside a square root must be 0 or positive. 0 to infinity. Okay, so here's the first way you start, is find the original domains. Okay, I will put some operations here momentarily. Okay, so here's the first three we will take a look at. So the first one is going to be f of x minus h of x. Okay, so I'll just write them down. I use parentheses because these are quantities. So we have x squared plus 1 minus h of x, which is x plus 3. And the reason I use parentheses is because when you subtract, this minus sign must be distributed. It's very easy to forget this. The first parenthesis can be dropped because there's nothing in front that has to be distributed. So this just stays x squared plus 1. But now when you distribute the minus sign, you get minus x minus 3. And we just have to combine like terms. X squared minus x and 1, and minus 3 is minus 2. So there's the subtraction. Okay. So then we will find its domain. Well, this original domains were all real numbers, all real numbers. This is another quadratic, all real numbers. Okay. I'm going to change B really quick. Okay, so I've changed part B to g of x times p of x. Okay, so in order to do this problem, we need to take g of x, 2x to the negative first, and multiply it with p of x, 5x to the 1/2. Notice I did not use parentheses because there's no plus or minus signs, so it's okay. Let's change this 2x to the negative first into 2 over x times 5 over x to the 1/2. This 5x to the 1/2 is over 1, so let's multiply straight across, and we have 2 times 5 is 10x to the 1/2 over x. And now I think I need to simplify that x's, right? I have 1/2 minus, there's a 1 down here, minus 1. Well, 1 is just 1 over 1, which can be made into 2 over 2 by multiplying top and bottom by 2. So we get 1/2 minus 2/2 is negative 1/2. So we will have 10x to the negative 1/2, but that cannot be our final answer. Well, it could be your final answer. That's fine with me today in this problem. Or, I'll go up here, or you can make that 10 over x to the 1/2. Okay, so we're kind of laid back when it comes to the answers here. But now I want to know the domain. So if you look at the original functions, okay, g of x said x cannot be 0, right here. And for p of x, x can be 0 or greater. So when you combine them first, now x cannot be 0. Because this says x cannot be 0, this says x must be 0 or greater, so we can only take greater than 0. So right now that's my domain, greater than 0. I look at my final answer and I say, okay, this is a square root. X has to be greater than or equal to 0, but x is in the bottom, so it can't be 0. And that is exactly the same domain as when looking at the two original functions. 0 to infinity. From 0 to infinity, and you cannot be 0 because of where the x goes to the bottom. Okay, that's a difficult one, so I'm glad we changed that one. Okay, and then the last one over here, p of x over h of x. So p of x is 5x to the 1/2 over h of x, which is x plus 3. And you might think that there's something to do, but there's nothing to do here. This is done. Now, the domain. Now, the domain is very interesting, okay? Because you have two things. First, you have p of x. P of x, original domain, greater than or equal to 0. H of x is in the bottom. And x plus 3, this cannot be 0. Okay? Even though x plus 3 has no domain issues, x plus 3 cannot be 0. So, if you take a look at the original domain, 0 to infinity, what value of x would make this bottom 0? Well, x would have to be negative 3. So x cannot be negative 3. So if that is in the original domain, we'd have to exclude it. Well, we're lucky that the original domain is 0 to infinity, right? Because of this square root up top. So there's no need to include this negative 3. Okay? However, I would like to change this problem just to show you what would happen. What if the problem, so this is the answer. What if the problem was x minus 3? Now, to make that bottom be 0, x would be equal to 3. So now x cannot equal 3. 3 is in this domain. 3 is in there. So here's how you'd have to answer the domain for this one. You could start at 0, and you'd have to go to 3. And you cannot be 3, so you'd have to put a parenthesis. And then you'd pick back up at 3 and go to infinity. And that would be the domain for this problem right here. So I'll circle that. All right. So pay close attention to this problem. You have to look at both the numerator and the denominator. Numerator greater than or equal to 0. Denominator cannot be 3 here, which is greater than 0. So you have to exclude that in your final answer. All right. So again, that's a very tricky problem, and you might see that again. Okay, and finally we'll end with a couple compositions. So again, I cut and pasted my functions down there. So just continue your notes. F of g of x. So we are taking g and putting it into f. So what I'll do is I'll put f of, and what g of x is. I'm sorry. I do not want g of x. I want h of x. Let me pause it and fix it. Okay, so I apologize. This is what I wanted to say. F of h of x. So I want h to go into f. Okay, so we're going to take out h of x and put x plus 3. So essentially what we're doing is we're just evaluating the function f for x plus 3. That means this function f, I'm going to write it without the x, squared plus 1. And where the x was, I will put x plus 3, and because it's two things, I'll put it in a parenthesis, x plus 3. And now you need to simplify this. Well, x plus 3 squared, you need to write out as x plus 3 times x plus 3. And you need to FOIL it. X squared plus 3x plus 3x plus 9, and then the plus 1 comes down as well. And when you combine your like terms, x squared, 3x and 3x is 6x, 9 and 1 is 10. There is your new function. I would like the domain of this function. So when you do the domains here for these compositions, you first look inside at h of x and you say, okay, what x's could go there? Well, h of x is x plus 3, that's all real numbers. And then you look at the final answer and say, okay, this is a quadratic, parabola, arrows on both ends. X can be anything. There we go. Okay. Now, this one, for sure, p of h of x. H of x now is going to go into p of x. So we'll take p of, and I'll replace h of x with what it is, x plus 3. And I'll say, okay, I'm going to write p down, 5. And this time I'm going to use the square root notation. But I'm not going to put x. I'm going to put what I'm evaluating for, and that's x plus 3. And again, you might think there's more to do, but there's not. This is it. Now the tricky part here is the domain. Because again, we look at the inside function, x plus 3, all real numbers. But then look where we're putting that. We're putting it into a square root. A square root must be greater than or equal to 0. So we need to find the value of x that makes this 0. And that's an x value of negative 3. And we say, okay, can it be negative 2? Yes, that'd be positive 1. Can it be positive 1? Negative 1. Yes, that'd be positive 2. So you can be anything greater than or equal to negative 3. And that's exactly what the domain is. And there we go. So practice those domains. They're tough, but there's only two exclusions, denominators and even indexes. Okay, very good. Okay, so here's one of those shopping problems involving compositions of functions, okay? So it says a clothing store is having a 35% off sale. Because you are a valued customer, you have an extra 15% off coupon. Find the two compositions and then which discount will the store use first. So we're going to have two functions, f of x and g of x. F of x is going to be the price of your purchase with the 35% off discount. Well, if you get 35% off, you have to pay 65%. There we go. G of x is going to be, so this is with the 35%. G of x is going to represent what happens when you get the 15% off. Well, if you get 15% off, then you are paying 85%. So that's 35% off, 15% off. So let's do the two compositions. So let's do f of g of x. And we'll take f of 0.85x, right? That's what g is. And we're going to put g into f, which means we're going to write 0.65 times, and in place of x, we'll put what we're evaluating. That is 0.85x. Okay, and we'll go ahead and multiply this out to see how much, what percentage you're really paying for this, your items. And when I use my calculator, I get 0.5525x, and that's the first composition. So in the end, you're going to be paying about 55% of the original price. Now let's do g of f of x. Well, that is g of, and we put f in there, 0.65x, which means f is going to go into g, so I write down g, 0.85. I don't write the x, I write times what I'm evaluating for it, 0.65x. 0.85 times 0.65. Oh, we just did that. It's 0.5525x. And notice for this problem, because they're both percents off, the compositions come out to be the same. So to answer the question, which discount will the store use first? The store would use either discount first. Either discount first. And again, it's because they both come out to be the same, right? Here in this top one, they're saying, okay, let's do the 15% off first. But in the bottom one, it's saying, let's do the 35% off. So you have the coupon first in the first composition versus the sale first in the second one. And again, it doesn't matter. The store would use either discount first because the compositions come out to be the same. It's not always like that, so you need to pick the one that would make the customer pay more. That's what the store wants, for you to pay more money. All right, very good. Okay, for our next problem, we're going to look at inverse functions, and we're going to look at it 3 ways. So this says inverse function 3 ways, and here's the function in question. F of x equals negative 3x plus 2. So the first thing I would like to do is I'd like to make a table of values. So this is way number 1. A table of values, x and y. And I want to do these x values. Let's just pick some random ones, and we don't have to do that many. Let's do 3 is fine, okay, or 4, whatever. Let's do negative 3, let's do 0, and let's do 2. Those are my x's. So all I'm going to do is plug them in, and I'm just getting my original values, what would be on the graph. So negative 3 times negative 3 is 9, 9 plus 2 is 11. 0 times negative 3 is 0, 0 plus 2 is 2. 2 times negative 3 is negative 6, negative 6 plus 2 is negative 4. So what I've done is I've gotten 3 points that are on this line. So now the question is, what are the points that would be on the inverse of this? So I will provide you with another XY chart, and you will have to provide me with the points on the inverse of this function. So this is for f, and this would be for f inverse. Well, if these are your points for f, then remember, your domain and range switch. These points would just be backwards. 11, negative 3, 2, 0, negative 4, 2. And that's one way, we'll call that A, to find an inverse. Just take the points and flip them. Okay, second way, graph it. All right, so what I'm going to do, I'm going to take these 2 points, and I'm going to graph them. Just those 2 points because they're pretty simple. 0, 2, and 2, negative 4. Okay. And there's that line. This is f. So now I want to graph f inverse. Well, f inverse is just, and I'll use a different color, let's use green. It's just going to be these 2 points. Or we take these coordinates and flip-flop them. So this was 0, 2, so now 2, 0 is on our graph. This was 2, negative 4, so now negative 4, 2 is on our graph. So now we have 2, 0, and negative 4, 2, which are exactly the 2 points down here. And we would draw a line through that. And that's our f inverse. Now to check, remember, they are a reflection over the line y equals x. So if you can see, if I take this point and I reflect it over this line, I should come to here. If I take this point and reflect it over the line, I should come down here. And that's exactly what's happening. And any point on the line is exactly the same point on both. And that's a great illustration of inverse graphically. All right. So that's the second way. And the third way is to actually find it algebraically and verify. Okay, so let's see how we do this. Okay, so remember your domain and range switch. So that's the same thing you're going to do here with your x and y. So we let f of x be y, and then we switch x and y. X equals negative 3y plus 2. And now our goal is to solve for y. Get y by itself. Well, I'll subtract 2 from both sides first. And I'll get x minus 2 equals negative 3y. And then I'll divide by negative 3. And I would love you to do, people call it the Pretzel Method, right? To find what those actually become. Well, this is a 1 in front of that x. So 1 divided by negative 3 is negative 1/3 x. And this negative 2 divided by negative 3 becomes a positive 2/3. That's all I need. That's y. And y now becomes f inverse of x. Negative 1/3 x plus 2/3. Again, this is a line. Notice that the inverse is a line. I bet you this point right here is 2/3 right there. And then the slope would be negative 1/3, because that's what this is, mx plus b form. Okay. So now I want to verify whether these are truly inverses. So let me slide my down. To verify, remember you have to find two things. F of f inverse of x and f inverse of f of x. So let's find f inverse of f of x. That means I'm plugging in f inverse into f. So I replace f inverse with what it was, and I plug it into my function f. Remember, f was negative 3x plus 2. So I'm going to write negative 3. I'm going to leave out the x plus 2. And where the x goes, I'm going to put negative 1/3 x plus 2/3. Kind of squeeze it in there. When I distribute the negative 3 times negative 1/3, the 3's cancel, the negatives cancel, I just get x. Negative 3 times 2/3, the 3's cancel, and negative times positive 2 is minus 2. So that's the distribution. And this plus 2 is in there at the end, and minus 2 plus 2 cancel, and there's, of course, my x. And that's what I should get. The inverses undo each other, so I should get x. Now the same thing should happen down here. So let's take f inverse of f of x. We're plugging in f of x into f inverse. So I'll write my f inverse, negative 1/3, leave out the x, plus 2/3. In place of that x, I'll put negative 3x plus 2. Distribute the negative 1/3. Negative 1/3 times 3, they cancel. The negatives cancel, and I just get x. Negative 1/3 times positive 2, you're going to get a negative, and that 2 goes to the top only, 2/3. And I bring the plus 2/3 behind. Minus 2/3 plus 2/3 is x. So I'm going to create a second video, starting with another inverse problem and then moving on to solving equations. Alright, so thanks for watching. Stay tuned to the next video.